Okay guys, what we're going to do now is we are going to look at what we call the converse of Pythagoras' theorem. Okay, now the word converse, you see that sort of build up of a word quite frequently in maths. Okay, in the past we've used the word reverse, we've used inverse, okay, and you might have noticed that they always have something to do with going backwards or reversing something basically. And that's the same with the word converse. So when we talk about the converse of a theorem, it just means we're looking at basically the opposite of the theorem, okay? And with Pythagoras' theorem, the converse means that we can prove that a triangle is or is not a right-angled triangle based on the side lengths, okay? So we're going to look at how to do that right now. Okay, so again, we have a triangle. Now, in this case, I'm not going to draw it as a right-angled triangle because we don't know. Okay, we don't know the sides of this one. We don't know if this is a right-angled triangle. We're going to hope that it is, but we don't know it. Okay, so let's try with firstly, we'll do one that I know will work first. Okay, so we'll say that this is 5 centimeters. Whoops. This here is 5 centimeters. This here is 12 centimeters. And this is 13 centimeters. Now let's say that I've said to you guys, okay, I want to know, is triangle let's use PQR, is triangle PQR a right-angled triangle or not? Okay, and we need to decide. Now, we're going to use the converse of Pythagoras' theorem. You don't necessarily need to call it that, okay? We're basically just using Pythagoras' theorem to prove if this is a right-angled triangle or not, okay? Now, when we're doing that, the first thing is, remember we always said that the hypotenuse is the longest side. Okay, and that's really important when you're doing this converse theorem. Okay, it's really important that you remember that the hypotenuse is the longest side. Okay, because that's the first thing you need to do. You need to decide which side would be the hypotenuse if this is a right-angled triangle. Now you can see here we have 5, 12, and 13. 13 is the biggest number. Okay, so we're going to assume that this is the hypotenuse if this is a right-angled triangle. Okay, so that's going to be our side that's going to be the c squared. Okay, now again we want to start just quickly by naming the sides. So remember, opposite angle Q is side Q, opposite angle P is side P, and opposite angle R is side R. Okay, so the way we are going to do this is we know that, as we said, Q should be the hypotenuse if this is a right-angled triangle. So we know it's going to be equal to Q squared. Okay, and our other two letters are P squared plus R squared. Okay, so if this is a right-angled triangle, this will be true. So if this is a right-angled triangle, this will be true. Okay, and we can now test this using our numbers. This is quite similar to in the past when we've looked at, is point A on the line? Okay, we substitute the numbers in and we see if it works. Okay, we're going to do that here now. So P was 12, so we're going to say 12 squared plus R was 5, so 5 squared is equal to, Q is 13, so 13 squared. Okay, and as I said to you, I know this one is going to work. I picked these numbers deliberately. Okay, so let's just go through and show what happens if it is true. Okay, so 12 squared, we know from the last unit that that's 144 plus 25 is equal to 13 squared, which is 169. Okay, 144 plus 25 is, surprise, 169 is equal to 169. Okay, now this is true. Okay, 169 is equal to 169, so we can say therefore triangle PQR is a right angled triangle. And we're done. Okay, now let's try one where it doesn't work. Okay, so I can show you what kind of result you'll get if it doesn't work. So we'll do another one. We'll make a triangle like this. Okay, we will say that it's going to be triangle KLM. Alright, and we'll make this side, KL can be 8 centimeters, KM can be 9 centimeters, and ML can be 13 centimeters. Okay, so again, let's start firstly by labeling our sides. So opposite angle K is side K, opposite angle L is side L, and opposite angle M is side M. Alright, in this case, again, the longest side is going to be our hypotenuse, and that's this one here, so that's side K. So our formula for this would be that L squared plus M squared is equal to K squared. Okay, remember the hypotenuse will be the one that's by itself. All right, now we substitute. So L is 9, so 9 squared, plus M is 8, so 8 squared, equals K is 13, so 13 squared. Okay, now 9 squared is 81, 8 squared is 64, and 13 squared is 169. Okay, 81 plus 64 is 145, is equal to 169. Now, is this true? No, it's not true. So, make that a bit clearer. We're going to make that 145 is not equal to 169 because it's not true. Okay, so we can say these are not equal, therefore triangle KLM is not a right angled triangle. Okay, and this is how we use the converse of Pythagoras' theorem.